Welcome back to the YouTube channel. Let me pick a color I like. We're going to do derivative of a composite function. Also known as chain rule. Now, before I continue, I'm going to relate you to something we've done before. For instance, let's say we wanted to take the derivative of a square root. And once again, I'm not crazy about purple. If I wanted the derivative of a square root, you might recall that in some other lessons, we took the square root and changed it to power of 1/2. And then you might recall with the power rule, we can now transition this expression into its derivative. Make sure you realize that the 1/2 just becomes the multiplier. The new power is going to be x to the 1/2 minus 1. So that's going to lead to 1/2 x to the negative 1/2. And we're pretty happy. Now you can revert this back to 1/2 squared x. There's situations where you might prefer it in the second form. So that's a situation involving the parent function. Now, you're also going to have situations where you're going to have the parent function, and instead of x, it's going to be the square root of a quadratic. That is an example of a composite function. Yeah, this is the square root of a quadratic. So when you have a square root of a quadratic, you not only have to consider the derivative of the square root, you also have to consider that that function within the square root has its own derivative, and you have to multiply by that derivative. So in this particular example, you're still going to go through the same process as before. You're going to rewrite the expression as x squared plus 9 to the 1/2. And then just to kind of shorten the process, the derivative is going to be expressed as 1/2 times the quadratic expression raised to the negative 1/2. But because this function is composed of a quadratic, you have to multiply by the derivative of the quadratic. So that's going to be what I'm going to write next. Then after you get that situation going, you're going to go ahead and rewrite this as 1/2 times the quadratic raised to the negative 1/2 times the derivative. Remember, the derivative of x squared is 2x. The derivative of 9 is 0. Now, this isn't necessarily completely done. You might notice that we have 1/2 times 2. So you can take 1/2 of 2 and create this expression where it's going to be the quadratic raised to the negative 1/2 result times x. And yes, even though you may not want to do it at this point, you can rewrite this expression as x over the square root of x squared plus 9. Either one of these expressions is correct and simplified. Tune in for more tips on how to survive derivative problems and composite situations in calculus and business calculus. Thank you.